Hey everyone, and welcome. Today, we're jumping into a really cool problem. What do you do when a super smart AI gets completely blinded by something as simple as fog? We're going to break down how a team of engineers came up with a clever way to teach it to see right through the haze. All right, let's get into it. So, picture this. You've got this high-tech security system, and it's powered by a state-of-the-art AI. This thing is supposed to be the perfect watchman, right? It never sleeps, it never gets distracted. But what happens when its whole world gets covered in a thick, disorienting fog? That's the huge problem we're going to unpack today. And this isn't just some hypothetical question. A super popular object detection model called YOLO, which by the way stands for You Only Look Once, is amazing in clear weather. But when the fog rolled in, it started to fail. It began seeing things that just weren't there. We call those false positives. And for a security system, well, that's a total deal breaker.
So, what do? You don't just scrap the whole system and start over? Nope. Instead, the engineers came up with this brilliant, three-pronged attack to make their AI way smarter and a whole lot tougher. Let's dig into exactly how they did it.
The first part of their plan starts right at the source, the data the AI learns from. And the idea here is actually pretty simple. If you want an AI to understand what a foggy world looks like, well, you've got to show it a foggy world.
They did this using a technique called data augmentation. And what's so cool about this is that you don't have to sit around and wait for 1,000 foggy days to collect photos. It's kind of like you're photoshopping. You're just digitally adding fog to thousands of clear pictures so the AI learns exactly what fog is and, just as important, what it isn't.
And here's the workflow broken down. It's super straightforward. First, you start with a perfectly clear image that the AI already knows how to read. Then, you use a special tool, in this case, one called Albumentations, to digitally paint on a layer of really realistic-looking fog. And finally, you feed that brand new, foggy image back to the YOLO model as new training material. You just do that over and over and over again, and pretty soon, the AI starts to get it.
Okay, so trick number one is in the bag. But just having better data isn't the whole story. The AI doesn't just need to see the fog, it needs to learn how to see through it. And that brings us to the second trick in their playbook, teaching the AI where to focus.
This is where something called attention modules come into play. Honestly, you can think of this as giving the AI a kind of superpower. It's like putting blinders on a horse or giving it tunnel vision. It teaches the model to ignore all the distracting, hazy junk from the fog and to concentrate only on the solid shapes of the objects it's supposed to be looking for. Now, here's the trade-off, right? This does make the model a bit more complex, but the payoff you get in terms of focus is absolutely huge.
So, we've got better data, and we've got better focus. What's the last piece of the puzzle? Well, it's about understanding that sometimes you shouldn't rely on just one point of view. It's about bringing in the power of teamwork.
This final trick is called model ensembling, and the idea behind it is just beautiful in its simplicity. Get a second opinion. If the main YOLO model is looking at a foggy scene and it's just not sure, it can now turn to a partner model for help. For this project, its partner was a model called Faster RCNN, which is known for being super accurate. By combining their two opinions, the system could make a final decision with way more confidence.
Okay, so that's the three-part strategy. Better data, a focus mechanism, and teamwork. The million-dollar question is, after all that clever engineering, did it actually work? Did they solve that false positive problem?
Oh yeah, the results were seriously impressive. This chart shows the model's accuracy score. All you really need to know is that a higher number is way, way better. Before they made any changes, the model was scoring a 0.71. After they put all three of these techniques into practice, that score rocketed up to 0.89. And let me tell you, in the world of AI, that is a massive leap forward.
Let's just boil all that down to one big, powerful number. That jump from 0.71 to 0.89 is a 25% improvement in detection accuracy. So this wasn't just some tiny little tweak. No, this was a game-changing breakthrough that made the AI fundamentally more reliable, even when the weather was terrible. So what are the big lessons we can pull from all this? Let's quickly summarize the workflow and the tricks that led to this awesome success, because these ideas can be used to solve all kinds of AI problems.
The key takeaways are pretty clear. First, you've got to train your AI with data that actually looks like the messy, real world it's going to operate in. Second, give your AI tools to help it focus, but remember that there's that trade-off with making it a bit more complex. And third, use the power of teamwork. model ensembling, to get a second opinion on the really tough cases. These tricks aren't just about seeing through fog. They're a blueprint for building smarter, tougher AI for any challenging environment.
And that really brings us to the big picture here. This whole project was about way more than just fog and security cameras. It's a proof of concept. It shows us that with the right data, the right tricks, and the right architecture, we can build AI that works reliably even when conditions are far from perfect. It really makes you wonder, doesn't it? If we can teach an AI to see through fog, what other human limitations could it help us overcome next?